Hello students, today we are going to discuss about integration by using method of partial fractions and long division. This process is followed for integrating the rational functions, either they are proper rational functions or improper rational functions. Now, if we recall few things about a rational function, it is defined as the ratio of two polynomials in the form of px by qx, where px and qx are polynomials in x, and this denominator qx is not equal to 0. And if the degree of px is less than the degree of qx, then the rational function is called proper, otherwise it is called as improper, right? So the improper rational functions can be reduced to proper rational function by using a process which is called as long division method. So if a rational function px by qx is improper, then we can divide numerator by denominator and express this rational function as your quotient plus remainder times denominator. Okay, right? Tx plus p1x upon qx, right? This is termed as quotient plus remainder upon denominator, where tx is a polynomial in x and p1x upon qx is a proper rational function. In this way, we will be getting a proper rational function. As we know how to integrate polynomials, the integration of any rational function is reduced to the integration of a proper rational function. The rational functions which we shall consider here for integration purpose will be those whose denominators can be factorized into linear and quadratic factors. Assume we want to evaluate integral px upon qx times dx, where px upon qx is proper rational function. Then it is always possible to write the integrand as a sum of simple rational function by a method called partial fraction decomposition. After this, integration can be carried out easily using the already known methods. The following table indicates the types of simple rational partial fractions that are to be associated with various kind of rational functions. So let's see the table. Now, if we are having the form of a rational function as px plus q upon x minus a upon x minus b, like linear upon quadratic it is, but the quadratic can be factorized into product of two different factors. Okay, then the form of partial fraction will be your a upon x minus a plus b upon x minus b. As soon as we will get the values of a and b, this will be splitted to the sum of two integrals, right, which can be integrated easily. Then second one is if the form is of px plus q upon x minus a whole square, means the denominator is having a perfect square type of fraction, then in that case this partial fraction will be your a upon x minus a plus b upon x minus a whole square, like this x minus a with the single power and then with the square power. Similarly, if it is x minus a whole cube, it will be taken as a upon x minus a plus b upon x minus a whole square plus c upon x minus a whole cube. Third part is if it is quadratic upon cubic, like px square plus qx plus r, and the denominator is having the product of three different factors. Same as in one, it can be factorized as using partial fraction a upon x minus a plus b upon x minus b plus c upon x minus c. And for number 4, it is px square plus qx plus r, where the denominator is having one repeated factor and one same one, right? So how will we go? We will take again the same process as number 2, right? So a upon x minus a, first with the single power, then plus b upon x minus a whole square, and then the third one plus c upon x minus b as it is. Okay. For number 5, if we are having quadratic in the numerator and denominator is the product of a linear factor and an irreducible quadratic factor, right? Irreducible means which cannot be further factorized, like in that case the partial fraction will be taken as a upon the linear factor which we are having plus bx plus c, right? Bx plus c upon the denominator is the irreducible quadratic, like x square plus bx plus c. Okay, in all these splittings, the values of a and b will be calculated, and those values will help me to break this into integrals, simple integrals, which can be directly integrated. So let us see how to find the values of a and b. Before starting with the numerical problems, let's have an overview of integration of rational functions. Any rational function can be integrated by following two steps. Express it as a sum of simpler fractions by using the technique called partial fraction technique. Okay, then integrate each partial fraction using the integration techniques that we have learned. For example, there is a integral which is x plus 5 upon x square plus x minus 2, in which the denominator can be expressed as the product of two different factors like x minus 1 and x plus 2. Okay, so the partial fraction for this form will be your a upon x minus 1 plus b upon x plus 2. And by getting the values of a and b, we can express this as the sum of simple fractions, okay, which can be integrated here, like 2 upon x minus 1 as 2 times log mod x minus 1, and 1 upon x plus 2 same as minus log mod x plus 2 plus c. Okay, and if fx upon gx is not a proper fraction, right, means the numerator is of lower degree and denominator is of higher degree, right, that one is called as a proper fraction. Okay, if it is not of that kind, like means it is inverse of that, like the numerator is having greater power, greater degree, and this your denominator is having less degree, in that case, just to make it a proper one, what I need to do is I will divide. I will use long division method, and by this method I'll be able to split this fraction into the form of quotient plus remainder upon denominator. Okay, so quotient will be a linear function which can be integrated easily, and the second one will be a proper one which can be integrated either by partial fraction method or by the method we have learned for linear upon quadratic, whichever is simple. So let us take questions. So my question number 1 which I'm going to take is from exercise 7.5, and I'm going to take my first question as simple one, and that is your question number 1, that is integrate x upon x plus 1 into x plus 2. Now as per the table that we have gone through, the partial fraction for it will be your x upon x plus 1 into x plus 2. It will be resolved to the partial fraction of a upon x plus 1 plus b upon x plus 2. Okay, now there are two ways of getting the values of a and b. So one I will discuss towards this side, and the other one I'll discuss towards this side. Okay, so let's see this one. Now take the LCM, and by taking LCM it will be like a upon x plus 1 into x plus 2, and it is a upon x plus 2 plus b x plus 1, and it is x plus 1 into x plus 2. So this will be cancelled, and I'll just get a times x plus 2 plus b times x plus 1. Okay, now I need the values of a and b. For it, firstly, what will I do? See this factor and equate it to 0 to get the 0. So the 0 is x is equal to minus 2. Now put x is equal to minus 2 in this whole expression. So what you will get? You will get minus 2 both sides. Minus 2 is equal to, this will become 0 as minus 2 plus 2 is 0, is equal to b times minus 2 plus 1. So I'll get minus b as minus 2. So I'll get b as 2. Okay. And similarly, the second factor is x plus 1 equal to 0. So I'll put x as minus 1 to both sides. So what will I get? Minus 1 is equal to, now this term will be 0. So it is a times minus 1 plus 2. So a is equal to minus 1. Right? You can check it from here also whether my splitting is proper or not by putting the values here right? And now what has happened, that my integral is split to a simpler form, x plus 1 into x plus 2 dx, which is your integral minus a is minus 1 upon x plus 1. I'll split it also, plus integral b is 2 times x plus 2 times dx. Now this is your 1 upon linear, so it will be minus log mod x plus 1 plus 2 times log mod x plus 2 and plus c. Okay. Now the property of log and log m, which is your log m raised to power n, will be used here. Altogether, one more property, log a minus log b is equal to log a upon b. So both these properties I'll be using. So it is minus log of mod x plus 1 plus log mod x plus 2 whole square, the property this one I have used, okay, plus c. And now this is log a minus log b, so I'll be using it here as log of x plus 2 whole square upon x plus 1 and plus c. This is the desired answer. Okay, so the process breaks this integral to the sum of simple rational functions and which can be integrated easily. Okay. Now the other way, the other shortcut method of getting the values of a and b directly in the form of integral. So this is the second method, and this method can be easily used to integrate the fractions which are having different factors in the denominator, okay, and linear factors in the denominator. There it works well. So like, how will I go for it? X upon x plus 1 into x plus 2 dx. Okay, so I'm just directly splitting it here. So the two factors are x plus 1 and x plus 2. So I will write this x plus 1 plus x plus 2 here. And now what happens in the numerator? See, now in the numerator what is going to happen? I'll take the first factor x plus 1 as 0. Okay, x plus 1 as 0, that means my x is minus 1. Okay, x is minus 1. Now put everything here in this complete term. Okay, you have to put this complete x is equal to minus 1 in x upon, like, x plus 1 into x plus 2. But you know, if you will put it here, it will make it 0 and it will be your undefined term, right? So I'll not put it here, just I'll put it in the place of x upon x plus 2. So if x is placed as minus 1, what will happen to the numerator? It is minus 1 upon minus 1 plus 2. Okay, don't put it here, otherwise it will be undefined, right? Similarly, for the case of your x plus 2 equal to 0, see, x plus 2 equals x is equal to minus 2. Now I'll put this x equal to minus 2 in place of x plus 1, x plus 2. So where should I put? I'll not put it here. Okay, so I'll just put this here only in place of, okay, so means I need to just ignore it. Okay, so I'll just put it in place of x upon x plus 1. So it is minus 2 upon minus 2 plus 1. So see, it is minus 2 upon minus 2 plus 1. So what will I get? I'll get the integral as minus 1 upon x plus 1, and it is minus 2 upon minus 1 is your plus 2, okay, upon x plus 2 dx. So see, it is the same thing which I have got here for this question, and rest of the integration can be carried out easily, right? So with a little bit of practice, if you are able to split in this way, so that will save your time, right? So see one more. Now we will take question number 3. This question is also having non-repeated linear factors in the denominator. So it is 3x minus 1 upon x minus 1, x minus 2, x minus 3. So let us learn how to apply the direct partial fraction, means how we can split it directly from here. 1 upon x minus 1 plus upon x minus 2 plus upon x minus 3 and times dx. Now what will come in numerator? That will be the values of a and b. And how will I get them? So firstly put x minus 1 as 0. That means x equal to 1. So where should I put? I will put it here in this expression except the term which will be reduced to 0 and make this expression as infinity. That means I'll put x equal to 1 just in 3x minus 1 upon x minus 2 into x minus 3. So what will it give me? It will give me your 2, 3 minus 1 is 2 and denominator is your 1 minus 2 is minus 1 and 1 minus 3 is minus 2. So it is 2 upon 2. Okay. Now the next one is your put x minus 2 is 0. X minus 2 is 0. That will give you x2. Now where will I put? I will not put it here. So I will put x equal to 2 in 3x minus 1 upon x minus 1 into x minus 3. So it will give me 6 minus 1 upon your 2 minus 1 is 1 and 2 minus 3 is minus 1. Right? So it will be your minus 5. Okay. So I'll get it here as 5 upon minus 1. Third one is x minus 3 is 0. Means x equal to 3. Where will I put? I'll put it everywhere except in this factor which is your x minus 3 in the denominator. So that means in 3x minus 1 upon x minus 1 into x minus 2. So it will be 3, 3. So it is your 9 minus 1 upon 3 minus 1 into 3 minus 2. So it will give me your 8 upon 2 into 1. So that means it is 4. So I'll directly write here 4. Okay. So with a little bit of practice, we can do it fast. Okay. So this is split it to 1 upon x minus 1 minus 5 times 1 upon x minus 2 plus 4 times 1 upon x minus 3. Okay. So the integral of 1 upon x minus 1 is log mod x minus 1 minus 5 times log mod x minus 2 plus 4 times log mod x minus 3 plus c. Okay. Now I will apply the process of, means I can just take them all together. So what can I do is I can apply the process of n log m is equal to log m raised to power n. Okay. So this will help me in expressing this as log x minus 2 raised to power 5 plus log x minus 3 raised to power 4 plus c. Now log a plus log b will be, what is log a plus log b? Log a plus log b is equal to log a into b, and log a minus log b is equal to log a by b. So it will be your log of x minus 1 into x minus 3 whole 4, okay, and divided by your x minus 2 raised to power 5 by using both these properties, plus c is the required answer. Let's take question number 19. So question number 19 is integrate integral 2x upon x square plus 1 into x square plus 3 dx. Now here we can see that the derivative of x square is present in the numerator. So put x square as t, so that 2x dx is dt. So I'll get it as dt upon t plus 1 into t plus 3. Now reduce it to partial fraction. So as the denominator is having two different factors, so we can do the direct splitting also. Okay. So 1 upon t plus 1 plus 1 upon t plus 3. So firstly I'll need to put t as minus 1, as t plus 1 is equal to 0 will give it to me, and I'll just put it in place of, not here, 1 upon t plus 1. So where will I put? In 1 upon t plus 3. So it will be your 1 upon minus 1 plus 3. And the second thing is t is minus 3. So where will I put t is minus 3? In 1 upon t plus 1. So it is your your 1 upon your, this is minus 3 plus 1. Okay, so minus 3 plus 1. So it will be your half upon t plus 1, and this is your minus half upon t plus 3 dt. So let us integrate it. Half upon, so integral of 1 upon t plus 1 is log mod t plus 1 minus half log mod t plus 3, okay, plus c. So can I take half common from them? So it is half of log mod t plus 1 upon t plus 3. Which property we are using? Log of a minus log of b is equal to log of a upon b. Okay. So now substitute the value of t. It is log of x square plus 1 upon x square plus 3 plus c, which is the required answer. Let us take question number 20 from your NCERT exercise, which is your 1 upon x into x4 minus 1 dx. Okay, the same question can be asked as 1 upon x into xn minus 1 dx. Okay, so how do we go for it? That here what we will do is we have to actually put this complete term x4 as t. Okay, because this is a biquadratic, so we cannot reduce it to partial fraction from here directly. Okay, so put x4 as t, so 4x cube dx is equal to dt, right? So x cube dx will be equal to dt by 4. So I'm not having x4 here, x cube here. Okay, so the first thing is just to multiply and divide by x cube, okay, into x4 minus 1 dx. So it will give me x cube dx upon x4 into x4 minus 1, right? Now see from here, if I'll put x4 as t, it will be reduced to, as x cube dx is dt by 4, so it will be your 1 by 4 dt, and this x raised to power 4 is your t, and this will be your t minus 1. So I think very simply we have reduced it to partial fractions. So the partial fractions will be your 1 upon t plus 1 upon t minus 1. So let us make it directly from here. Okay, so firstly I need to put t as 0, but I'll put it in 1 upon t minus 1. Okay, so 1 upon t minus 1 will give me 1 upon 0 minus 1. And the second thing is I'll put t as 1, but only in 1 upon t. So it will be 1 upon 1. So it is 1 upon 4 minus 1 upon t plus 1 upon t minus 1. This complete dt. So it is your 1 by 4. Okay, and it integral minus log mod t plus log mod t minus 1. So let us apply our log a minus log b. What is it? It is log of a over b, which is your 1 by 4 log mod. The value of t is x4 minus 1 upon x raised to power 4 plus c, which is the required answer. Now let us take question number 21. It's a very good question. You have to integrate 1 upon ex minus 1 dx. Now by looking at this question first, it is very difficult to analyze what should I do with it. Means whether I should go for some may think that of log mod x form, or some may think of that we should break it to partial fraction. Yes, you can go for partial fraction method also, but the better way is to divide numerator and denominator by e raised to power x. So what will happen? It will be reduced to a very simpler form. Okay, so it is your ex minus 1 upon c. I'm dividing it separately. Okay. So I'll get e raised to power minus x dx here, and it is 1 minus e raised to power minus x. Now it has reduced to a very popular form, that is f dash x upon fx. Okay. And the answer to it is log mod fx plus c. So the answer is clearly from here, log mod 1 minus e raised to power minus x plus c, or we can simply write it as log of 1 minus 1 upon e raised to power x plus c, or log mod e raised to power x minus 1 upon e raised to power x plus c. Okay. Why? Because you can see that the derivative of this is, the derivative of 1 is your 0, minus e raised to power x will be your e raised to power minus x, and ddx of your minus x is minus 1. So it will give you the derivative as e raised to power minus x. So that's why it's had changed to f dash x upon fx form, which can be integrated as log mod fx plus c.